And of course, we still have that homework for this lesson. So after you hear this, just 20 minutes of your time will be quick, and then you can do the homework pretty easy. I shortened to only 3 questions because the material isn't too hard. So let me just share the screen. So can everybody see my screen? Can everybody see my screen? If you can see my screen, then say yes. Okay, Zivo, you already did the homework. That's good. Well, if you already did do the homework, you already know how to do the homework, then you don't need to come to this extra lesson. Okay, this is only for the people whose video lesson did not work. Okay, so if you already did it, then you don't have to. But if you want to listen to it again, then you can. All right, so just real quick. Yeah, the entire class, right, is extra because I already posted a video lesson. I already posted a video lesson a while ago, right? Over break because we had too many missed lessons because Easter, that kind of stuff, spring break, you know. All right, so I this is not a like an overtime lesson thing. This is just a makeup of that lesson. All right, we'll have actual class starting next week. All right, so actual class starting next week. This is just makeup for people who did not work. Okay, so for this lesson 2 of solving inequalities, pretty easy. You know, the graphing the simple inequalities, right? So and then this says class schedule. Some homework questions, graphing simple inequalities, going over interval notation, and then practice problems. Pretty easy, right? Nothing to worry about. So let's just go over our homework questions real quick. So if you could, everybody just post your answers for this. All right, everybody just post your answers for this. All right. And then I'll go over it for this video lesson. Okay, should be quick. If you pull up our last lesson's homework, then you can just put it in. All right, I'll go over it now. So this is just distributive property. All right, so distributed is 18x plus 6 is less than 9. All right, then 18x, right, is less than 3x is less than 3 over 18 is 1 over 6. All right, so hopefully that's what everybody got, right? Hopefully that's what everybody got. Okay. And then actually I'll just don't want to waste too much time, so I'll just go over each of these homework questions. All right, so this one, pretty easy as well. Just multiply 3 to both sides, right? 2x plus 1 is greater than or equal to 15, right? So 2x is greater than or equal to 14. Then divide both sides by 2. X is greater than or equal to 7. So next one, right? Remember we have to multiply 4 to everything. 3x plus 8x is greater than 8. All right, so multiply 4 to everything. So 11x is greater than 8. All right, then divide everything by 11. Okay, yeah, x is greater than 8 over 11. So it's fine now, right? So everybody got 8 over 11, okay? So 8 over 11. Okay. So after we do these homework questions, already we have a few slides. We're going to review inequalities, and we're just going to graph and interval notation. So if you have any events or anything you have to do after this lesson, this is only going to take about like 20 minutes. I'm not going to waste too much of your time. Okay, so this one's the makeup lesson. Just joined. Okay, and then for our 4th homework question, okay, from the last lesson, you multiply everything by 3, right? So this is pretty easy. So multiply 25 by 3 is 75. plus 2x, because the 3 on the bottom cancels out, is less than or equal to 30. Oh, not 35. Okay, it's 3 times 35, which is 105 minus 3x. Okay. Then if you want to move the 105 to this side, then you get like negative 30. Okay, this less than or equal to negative 5x. And this is perfect opportunity to practice our remember when you divide by what, a negative, right? When you divide by a negative, you have to flip the sign. All right, you have to flip the sign. So this less than or equal to turns into greater than or equal to, right? So divide by -5, get x is less than or equal to 6. And so did everybody get less than or equal to 6 on the homework? Hopefully everybody got less than or equal to 6. All right. And then we have our last one. This one is the hardest. Okay, so we have the 3 and the 2 on the bottom denominator, right? So all you need to do is you need to find the least common multiple of 3 and 2, which is 6, all right? And multiply everything by 6. So both things cancel out. So if you multiply this side by 6, all right, so x over 3 times 6 is 2x, plus 3x over 2 times 6 is 9x, is less than x plus actually 6x plus 36. All right, then this 5x is less than 36x. All right, not equal, less than. All right, remember, divide both sides by 5, you get it's less than 36 over 5. All right, so hopefully everybody got 36 over 5, right? So 36 over 5, just a quick review of last time. So now let's go over our inequalities, how we solve them if you did not get it the first time. So the definition of an inequality, remember, it's the relation that makes a non-equal comparison between two numbers or mathematical expressions, right? So that's not equal, right? So different from an equation, it's not equal anymore. And some inequalities include like 3 is less than 4. All right, so 3 is equal to 3. That's an equation, and that's not an inequality. Maybe 2 is less than 3. All right, those are inequalities. And for the algebraic inequalities, you can have like 2x is greater than or equal to -4. Okay, as long as it's not equal, all right? Or it can be equal sometimes, but it's not equal comparison, right? So it can be it's like greater than or equal to, but it's all still like greater to, greater, right? It's not equal comparison, right? So let's go over the types of non-equal comparisons we can have, all right? So we have 4 different signs. We have the less than. Okay, so x, let's say the x is less than a. Okay, so this is the less than. Okay, so and then this is the greater than. Okay, and similarly we have this type of sign. We have the less than or equal to. Right, so it has to be less than, but it can also be equal to, right? And then again we have the greater than or equal to. So remember these signs. Everybody's got it so far. That's good. All right, these are our signs. And then we have we're going to review how to solve inequalities. So the tips for solving inequalities, right, is solve very similarly. Similarly to the linear equation. All right, so solve very similarly to the linear equation, right? So simple equations, all right, it's solved very similarly, right? Inverse operations. So inverse operations. And so inverse operations, just use inverse operations to solve, all right? So, but key point, what's our key point here? Very important. So can anybody tell me what's our key point? So what's our key point? Who can tell me our key point? Right. We have who's raising their hand? 2. Okay. Who's 2? I don't there's okay. Just William and Zebo. Okay, so you can just unmute and blurt it out. What's our key point here? All right.
Key point is that when you multiply or divide by a negative number, you have to flip the sign.
The flipping inequality rule.
Yes, yes. All right, so what you need to do is you need to flip the sign. All right, so flip the sign when you divide or multiply by a negative number. All right, so when you divide or multiply by a negative number, right? When you divide or multiply by a negative number, right? Flip the sign. All right, so flip the sign. This is very important. Flip the sign. All right, so what do I mean by flip the sign? Can anybody tell me what do I mean by flip the sign?
Flip the sign means that you turn less than to greater than, or turn less than or equal to greater than or equal to.
For example, right? Less than turns into its opposite, which is greater than, right? So turn it into the opposite, right? When you're dividing or multiplying, finding a number, you flip the sign. Okay? And yeah, that's about it. Right. So make sure you flip the sign. And why is it divide or multiply? Because dividing is basically multiplying, right? Divide by 3, that's multiply by 1/3. So it's basically just multiplying by a negative number. But you can also say divide. So same. That's why it's dividing or multiplying by a negative number. Then you flip the sign. All right. So make sure you flip the sign. If you don't, then you can end up with the wrong sign. Then you get the problem altogether just wrong. Okay. So then the graphing inequalities. All right. So now we graph inequalities. So when we want to graph inequalities, right, we need to go from a point and we either go greater than that point or less than that point. For example, x is greater than 4. Which point are we going off here? If x is greater than 4, then we're obviously talking about the point 4 on this graph. It's the point 4, right? Then we're going off the point 4, and we're either greater than 4 or we're less than 4. Okay, so in this case, we're greater than 4. If we're greater than 4, then 2 is not a solution. 3 is not a solution. 0 is not a solution. Anything less than 4 is not a solution. So we disregard that. But 5 is, 6 is, 7 is, anything greater than 4 is a solution. So anything to the right of 4 is a solution. So we put our point on 4, which is an open circle, right? I'll talk about that later, whether it's open or closed. And since our equation here, our example equation, right? Example equation, right? Example is x is greater than 4, then our arrow, okay, it's going to be to the right of 4. So that's how we know. Okay, that's how we know. Now, what about the circle? So another key point. Oh, all right, subtle point. You need to make sure you know this. So an open circle, if this is an open circle, is for greater than or equal to, well, less than or equal to, or greater than or equal to. In this case, well, hold on. Made a mistake. Sorry. For open circles for less than or greater. Okay, less than or greater. Okay, that's right. Now the closed circle is for the less than or equal to, or the greater than or equal to. Okay, that's the closed circle. So if I made this x is greater than or equal to 4, all right, greater than or equal to 4, then this is a closed circle. So, right, so you have to distinguish between the circles. Now, I have a little trick when we're graphing these inequalities that make sure you know very fast which way the arrow is going, right? Which way the arrow is going, right? So you can check yourself. So whenever x is on the left-hand side, right, this sign, right, this kind of looks like an arrow, right? And where is it pointing? The arrow is pointing to the right. So that's how you know that this arrow is going to go to the right. That's a little trick. But you don't need to use it. Just increase your efficiency if you need it. Okay, so another example. All right, so let's do another example, and I'm gonna have you guys participate on this one. So let's have 5 is less than or equal. 5 is greater than y. All right, 5 is greater than y. All right, so how are we going to do this? So who can participate? All right, so who can? Oh, Zebo, you still have your hand raised, okay? And then William. Okay, so
forgot to
William, do
put
you
it
have
down.
any ideas? Or Zebo, do you have any ideas? Who spoke?
I forgot to put my hand up.
Oh, okay. All right, so William, do you have any ideas on how we graph this?
So we put the open circle at 5, and then put a right arrow, and then draw a right arrow across the number line.
A right arrow.
Mm-hmm.
Are you sure about this? Y is less than 5. Are you
Oh
sure
wait,
it's
what? Oh wait, then it's a left arrow.
left arrow, right? See,
Wait.
the trick only works if y is on the left-hand side, right? So if y is on the left-hand side, then it's less than 5. And this arrow is pointing to the left, like this. Is that an ice cream truck I hear?
Bruh.
I swear that's an ice cream truck. Where I live, it's like the winter, and it's like cold. It's no ice cream. Ah, you're lucky. Anyways,
Today,
Where I live, there were snowflakes falling.
same.
see, it's still winter, right? And yet it's April, and it's still winter. Such a long winter, you know. The summer is so short.
April
Right.
is spring.
Yeah, I know, but it's still cold, like winter in some places. So I know. Anyways, so it's an open circle, right? An open circle, right? An open circle. Why? An open circle. Why do we have an open circle, right? It's less than, right? Or greater than. Just strictly less than or greater than. Then we have open circle. But if this wasn't equal to, then we have closed circle, all right? So make sure you know that. So now let's go over to interval notation. Interval notation is also really easy, all right? So interval notation, once you know it, it's pretty easy. So an interval is basically a set of real numbers that contains all the real numbers lying between two numbers of that set, basically between 2 points. Anything between 2 points. Let's say I have the set 2, 3. This is an interval in interval notation. What does this mean? It means everything in between 2 and 3. It could be 2.5, it could be 2.4, it could be 2.3, it could be 2.22223. Anything in between 2 and 3. Basically, an interval is just all real numbers lying between the two numbers of that set. All right. So here's another subtle point, key point that you want to note when you have the interval notation, right? You have the interval notation when you have a set. Okay, so the different types of parentheses. Okay, the different types of parentheses you have to specify, right? So when you have the normal parentheses, right? You have the normal parentheses, right? the normal parentheses. This is the normal parentheses is not included. And I'll explain this later. Okay, what this means, and then the square brackets. All right, just write this down real quick. Is included. So what do I mean by not included and included? All right, so let's go back to our little example, 2 to 3. Right, so 2 to 3. So when we have square brackets over 2 and 3, right, square brackets means included, which means 3 is included in the set and 2 is included in the set. Previously, we had this 2 to 3 with regular parentheses, right? This means everything in between, strictly in between 2 and 3 are real numbers, not including 2 and 3. So it can be 2.1, but not 2. 2.9, but not 3. So 3 and 2 are not included. But in this one, with the square brackets, it's all the way from 2, including 2, to all the way to 3, including 3. All right, so that's included, right? So the number here is the endpoints are included, right? So it's just like the less than or equal to, it's included. Less than or equal to 5, all right? 5, it can be equal to 5. Or just less than 5, right? It's strictly less than 5, cannot be included. 5 cannot be included. So this is the same concept, right? So this is how we do it. So the interval notation. Now, what is the point of interval notation? Well, the point of interval notation is we're going to denote our inequalities with it, right? So let's have another example. Going to denote our inequalities. So far we have some solutions. For example, let's go back to the homework, like x is less than 36 over 5. So x is less than 36 over 5. So x is less than 36 over 5. Then we denote, okay, so denote as interval notation. Right, so how do we denote as interval notation? Can anybody help me with this? All right. So who is here? All right, Jenny, can you help me with this? All right, do you know how to denote this in interval notation? X is less than 36 over 5. All right, so who can help me with this? Does anybody know? All right. So if you want to give your answer out, you can type it in the chat, or you can just unmute yourself. So everybody unmute yourselves. See if you can help me with this. How are we going to do it? All right. All right. So how do we denote as interval notation? So how do we denote as interval notation, right? Between two intervals. So x is, well, obviously we know our point is,
I know how to do it.
right?
So it's like on the left side of the interval notation, so there's like two numbers, right? On the left side of the interval notation is negative infinity, I think. And then the right side is 36 over 5.
That's correct. Right, so negative infinity to 36 over 5. Right, because x is less than 36 over 5. It can be anything less than negative 36, anything less than 36 over 5. So it can go to infinity. If x was greater than 36 over 5, then it could go to positive infinity, right? And since, the first number here listed is the smaller number and the bigger numbers, this is second, then, it's less than 36 over 5. So 36 over 5 is second number listed, and then negative infinity is the first. So let's do another example, right? Another example. So let's do 5 is less than or equal to negative x. How do we denote this as interval notation? So who can help me with this? All right. Does anybody know?
Pretty sure it's
Yes.
pretty sure the lower end is no
Wait, net 5 is greater. I mean, less or equal to negative x.
Yes. I mean, it's not hard, right? It's not hard. It's pretty easy. Just solve the equation, then you do it.
Wait, so that
negative 5 is greater than x. Yeah. Yeah. Negative 5 is greater or equal to x.
Yeah.
And then, so you're lowering your bracket is 5, I think. And then top is negative infinity. Is infinity, I mean. Or something like that.
What the?
But 5 is supposed to be the bigger number, right? Because x is less than or equal to 5.
Oh, yeah. Oopsie. So, yeah, so negative infinity to 5.
And what's this bracket? What is this bracket? The last bracket?
It's a square bracket.
Yes, it's a square bracket because it's included, right? It can be less than or equal to, so it's included. Right, very
So-
good, very good.
I think
So
isn't
now-
that supposed to be square bracket too?
No, the negative infinity is not included because you can't include it, right? You can't include it. Negative infinity is quite intangible, right? It's intangible. It's negative infinity. It's infinity, right?
Oh,
You can't,
wait,
you know, can't be included in the set, right? Because infinity is really like quite abstract, right? So it's not included.
so if there's the equation like x is greater than 5, I mean x is less than 5, then x is greater than 5, then the infinity has the normal bracket, but the 5 has the square bracket. I mean, wait, 5 is greater or less than, I mean greater or equal to x.
Yes, right. The parentheses and the square brackets can go together. You can have one square bracket and one parentheses. Right?
Oh,
That's possible, right? It's possible. Right? So don't be too weirded out about that. It's possible. So let me just I'm not gonna waste too much of your time, so I'm not gonna ask you to do these. And plus you can't graph it really on a number line. So I'm just gonna walk you through this once. So the first step, of course, is to solve equations, which we already got down. It's pretty easy. So 3x minus 2 is greater than 40, right? So 3x is greater than 40. 2x is greater than 14. So now we've solved the equation, right? So now let's denote an interval notation. So if x is greater than 14, then 14 is the lesser number, right? And it's not included. It's not included. So both regular parentheses on each one. And then we have positive infinity on the top, right? And so now let's graph on our number line. So we have our 0 right here, and our 14 right here. Right? So not included, right? So open circle, then it's greater than. Right? Pretty easy. Now let's solve this one. Okay. So this one just multiply everything by 7. 3x minus 21 less than or equal to 35 plus 7x. Okay. Then you move the x's and isolate the numbers, right? So that's negative 56 on the side is less than or equal to negative 4x or plus 4 and positive 4x. Okay, so then x is greater than or equal to negative 14. All right, is that correct? Correct. Let's check it. So it's negative 42 minus negative 63. Okay, and then let's see here. 98. Yeah, I think it's correct. Yeah, correct. All right. So let's go back to our interval notation. And x is greater than equal to negative 14. So it's negative 14 is still the last number. So negative 14 here. And actually it can be included, right? It's included. Look, it's included. Then it's positive infinity here. Okay, so then you have our 0 here. We have the negative 14, and it's still greater than, but this time it's a closed circle because it's including. All right, so there we go. Next one, this shows property, pretty easy. Plus 20, less than. All right. Okay. We have this, we have our interval notation. X is less than this time. So negative 8 is actually the bigger number. And plus it's not included, so regular parentheses. It's bigger number, and this is negative infinity. Okay, so and our number line will be pretty easy too. So 0 on this side, negative 8 here, our not included, so open circle, and we're going to the left, right? So hopefully everybody got that. Does anybody have any questions?
Nope.
Okay, very good. Was that actually an ice cream truck? Was it? Oh, wow. Okay, thank you for listening, everybody. And I'll see you next week. All right, so this is just a makeup lesson for those who did not get it. So I already have like 5 people, 6 people turn in the homework already because their video lesson works. All right, so for those video lessons that did not work, get onto the homework real soon. It's due this coming Thursday. All right, so but it's just 3 problems. All right, it's just 3 problems. Takes like 10 minutes of your time to knock it out. It'll be pretty easy. All right, so good luck, everybody. All right, so I'll see you next time. All right, I'll see you next time.